Okay, good evening everyone. What we have this day is motion. As some of us will be having problem in motion, I'm here to treat some problems under motion. And before I proceed, I would like you to know that motion is categorized into two parts. We have kinematics and we have dynamics. Whenever you talk about kinematics, it's talking about motion without regarding the force that is causing such motion. But whenever you are talking about dynamics, it's talking about motion and the forces that are causing such a motion. Okay, so where we'll be basing our facts is on this kinematics part, and here we shall be treating concept of kinematics. Like we'll be treating distance, we touch also displacement, we also touch speed, we also touch velocity, we also touch uniform acceleration, and we also touch uniform retardation. Then we go into equations of uniformly accelerated / retarded motion. Okay, by the time we're done with that, we go into problem solving involving all these concepts. So should we start? Let's start with distance. Let's start with distance. Whenever that word distance is mentioned, just take note that what is being talked about is separation between 2 points. Distance is the measure of separation between 2 points. For instance, if you have point A and you have point B, it's talking about separation between these 2 points. That is distance for you from this place to this place. It's called distance. And this distance is denoted as S. With that, we can go into acceleration. We can go into displacement. Displacement is almost related to distance. The only thing is in the terms of direction. For instance, if you take a look at this, assuming you want to go to this house from here, this is house A, this is house B. Now, if you take from this place to this place, in order to reach that house, and from here to here is 40 meters, from here to here is 30 meters. For you to calculate the distance traveled, what you will say is that distance or total distance traveled is equal to 40 plus 30 to give you equal to 70 meters. But in the terms of displacement, which I told you that displacement is likely the same thing as distance, but there is a difference in the terms of direction. For instance, if you take a look at that also, that this is your house, this is your friend's house, house A, house B. You want to travel from this point to that point, and from here to here is 40 meters. From here to here is 30 meters. For you to discover the displacement is the shortest route you take from the initial point to the final point. That's displacement for you. And the shortest route you can take is from this point to this point. That's the shortest route you can take. And you can call it what? Displacement. Okay? So for you to discover this displacement here, you have to use Pythagoras theorem method. Pythagoras theorem method, which means that hypotenuse side square is equal to opposite square plus adjacent square. Okay, so this displacement is at the hypotenuse side. That means that displacement S is also denoted as S. S square is equal to 40 square plus 30 square. To give you S square is equal to 1600 plus 900. That shows that S square is equal to 2500. S is equal to square root of 2500, which is equal to what? 50 meter. So it is telling us that displacement S is equal to 50 meter. What am I talking about? You discover that displacement is the shortest route from the initial point to the final point, which is also telling us that it is also dealing with direction. But distance is not dealing with direction. Distance is just concerned about the magnitude, the value, the separation. So you can say in a nutshell that distance is a scalar quantity and displacement is a vector quantity. Okay, let's move into the next concept. You know that after displacement, the next concept we have there is what? We have speed. I can say that speed is a parameter you can use in measuring distance with respect to time. It is a parameter you can use to measure distance with respect to time. For instance, you can say that speed is the rate of change of distance. Whenever you mention rate, it means something divided by time. Okay? So speed being denoted as V is equal to change of distance with respect to time. That is equal to distance over time taken. Okay? So if distance is that, you can say that average distance, average speed V is equal to total distance over time taken. Total distance over time taken. Okay? So mathematically, you can say that V, speed, is equal to distance over time taken. Take note of this. The SI unit of speed is meter per second. Or you can write it like this. It is meter per second. That is the SI unit of speed. I failed to tell you of the SI unit of distance and displacement, and that is what? That is meter. SI unit of this is meter. SI unit of displacement also is meter. Okay? So they are the same thing in terms of SI unit. The only difference is just that the other one is a scalar, while displacement is a vector. Coming to speed also, you know, speed, we are measuring distance with respect to time. That means that speed also is a scalar quantity. Okay? Let's get to the next phase. The next phase we are going to get at is velocity. Velocity. Velocity is a parameter for measuring displacement with respect to time. In a nutshell, you can say that velocity V is the rate of change of what? Displacement. Is the rate of change of displacement. And I said that whenever rate is mentioned, it means something divided by time. Okay? So mathematically, I would definitely say that velocity V is equal to displacement S all over time taken. Okay, so that means that average velocity is equal to displacement S all over total time taken. So take note of this. Take note of this. V is equal to S over T. It's still the same thing with the one on speed. The formula for velocity is the same thing with the one on speed that we mentioned here. We made mention of here. The only difference is that speed is a scalar because it is a parameter that is used in measuring distance with respect to time. But when you talk about velocity, it's a parameter that is used in measuring displacement with time. Okay, that's why I say that velocity is a vector quantity. And whenever you are solving things that involve velocity, they ask you to find velocity of something. Just know that it's just the same formula, and the SI unit is the same. The SI unit of velocity, the SI unit of velocity V is also meter per second. Okay, so let's get to the next concept. The next concept we are entering is uniform acceleration. Uniform acceleration. In this uniform acceleration, I can say that uniform acceleration is the rate of positive change in velocity, in a straight line. Okay, so just take note of this concept, uniform acceleration. That means it's also possible you can have another form of acceleration, which can appear in form of instantaneous acceleration. But whenever you hear of uniform acceleration, just take to your mind that they are talking about acceleration in a straight line. And acceleration generally is the rate of change in velocity. And because we are talking about acceleration, you have to put that positive change, just take note of this word, positive change in velocity in a straight line. Okay, so mathematically, you are going to say that uniform acceleration A is equal to positive change in velocity over time taken. As I told you that whenever you hear of rate, it means divided by time. Okay, so acceleration A is equal to positive change in velocity over time t. That means that A is equal to V minus U all over t, where this young man here is final velocity and this young man here is initial velocity. Okay, so acceleration or uniform acceleration is equal to final velocity minus initial velocity all over time taken. So since from the definition I said that uniform acceleration is the rate of positive change in velocity with time. That means that if there is something like positive change in velocity, that means that automatically it is possible to have something called negative change in velocity with time. Okay, so that is where another concept will come in. But take note of this, that A is equal to V minus U all over T. Just take note of this. So because of this negative change in velocity, that introduces another concept, and that other concept is what? It is uniform retardation. Uniform retardation, and you can also denote it as A. So I can define uniform retardation as the rate of negative change in velocity in a straight line. Okay, so uniform meaning straight line, while retardation meaning negative change in velocity. Whenever they mention about rate, it means divided by what? Time, as I always say. That means that mathematically you can have that uniform retardation, which is as well denoted as A, is equal to negative change in velocity. Delta means change, all over T. That means that A is equal to minus, meaning negative, change in velocity, final velocity minus initial velocity, all over T. Okay, when you open this bracket, you are going to have A is equal to minus V plus U, all over T, which means that A is equal to U minus V, all over T. Take note of this. This is for what? Retardation, while this one is for acceleration. Okay, take note of that. So we have to enter into another concept. And what is that other concept? The other concept we have to look at is we have to look at equations of uniformly accelerated or retarded motion. Okay, there are mainly three equations that we have to look at here, and those three equations we have to categorize them into two departments: acceleration department and retardation. Coming back, as I told us earlier before that, we are going to look into this concept, equations of uniformly accelerated stroke retarded motion, because that you have some motions that are accelerated and motions that are retarded. Okay, so we are going to look at the two equations and we are going to categorize them under two departments: acceleration department and retardation department. Okay, so in acceleration department, the equations are up to three: equation 1, equation 2, and equation 3. The first equation is V is equal to U plus AT. Second equation, S is equal to UT plus half AT squared. Third equation, V squared is equal to U squared plus 2AS. Coming here, which is also 1, 2, 3. What we are going to have is V is equal to U minus AT. Here you have S is equal to UT minus half AT squared. Here you have V squared is equal to U squared minus 2AS. You notice something here, right? Whenever acceleration is being mentioned, you know that it denotes positivity. That's why you see positive sign here, here, and here. Coming to the retardation category, you are seeing negative sign here, here, and here. Okay, showing us that acceleration is dealing with positivity, while retardation is dealing with negativity. I forget to tell you something. Take note that both acceleration and retardation has words. Both of them has denotation as A, and as well the SI unit of both is meter per second square, or it can be written like this: meter per second square. Okay, so just take note of that. So these are the three equations we have. Before we answer questions concerning these equations, I want us to answer two questions here. And what are those questions? Number one question is, how do I know acceleration or retardation question. Okay, so answer. How you know acceleration question is when they say a car, a ball, or any object, when they say it starts from rest. Okay, mark this word. When it starts from rest and accelerate with so rate. That means that what happens there is acceleration. Notwithstanding that acceleration happens there, you should take note of this from rest. From rest means that u is equal to initial velocity is equal to 0 meter per second. Okay, so but when they say a car comes to rest, or something was brought to rest, or that a brake was applied, and something comes to stop, it means it is retardation question. Okay, and notwithstanding that is retardation question, it means that at retardation v is equal to 0 meter per second. 0 meter per second. 0 meter per second. Okay, so and another thing which I would like you to note here is whenever a question is acceleration question and they say it starts from rest, that means that any other velocity they gave you the value, it means that that velocity is your v, and from rest means that u is equal to 0 meter per second. But when you come to retardation, any velocity value or any value of speed they gave you, since the dimension comes to rest, it means that comes to rest v is equal to 0 meter per second, and any other value of speed they gave you is your u. Okay, so just take note of that. Then another question which I would like us to answer here is which equation do I apply among others in solving problems? Okay, so answer. First of all, you have to list out parameters. Then after listing out the parameters, assuming that that question you have already discovered that is a acceleration question or is a retardation question, after listing out parameters, then look at your parameters. Then if it is a acceleration question, shake your equation under acceleration department if it aligns with your listed parameters. Maybe first equation, that means you are going to use first equation. Okay, but if your listed parameters align with the second equation, that means you are going to use second equation. If it aligns with third, you are going to use third. But while taking note of this, you should take note of whether it is acceleration question or retardation question. Hope I've answered your question. The next time I'm coming, we are going to start solving some problems. Solving problems under motion. Okay? So just expect my next video. That is where I will solve necessary questions that will help us and help you as well as students that is listening to this video. Do well to subscribe to our channels, click on the view, click on that button there, tell your friends about it, share to everyone around you, share to your friends, to the people that are writing exams. You discover that this can be of help to you. Thank you very much.